So let's check this exam problem here. We have a concrete column with a strength of 5000 psi and gross section dimensions of 12 by 12 inches, and it is reinforced by 4 bars of number 9 of grade 60. This is a steel grade. We want to determine the design axial compressive strength and the reinforcement ratio. Okay, in order to start solving this, first step we need to determine the phi, and this is a concrete column. It is under compression, so phi for tight compression members equals 0.65. Next step, we will write the equation for the column design for the compression strength, which is phi Pn equals 0.8 phi multiplied by 0.85 Fc prime multiplied by area gross minus area steel plus area steel multiplied by F yield. We have all of these parameters. We know that the phi equals 0.65 and for the area gross, and also we know that the Fc prime equals 4, which is 4 ksi because we want the value per kips, and we know that the area gross is 12 multiplied by 12. This is a square section, equals 144 minus the area steel, which is 4 multiplied by the area of each bar of number 9, which equals 1 inch square. So the area steel, the total area steel equals 4 inches, 4 inches square of course. And as I told you earlier, we can get this value from the table of the steel reinforcement, which is in our FE reference book. All of this plus area steel, which is 4 multiplied by 60, which is the F yield. So this equals 434 kips, and this is the design axial compressive strength for this column. Regarding the reinforcement ratio, we will just simply determine it by rho, which equals area steel divided by the area gross, which equals 4 divided by 144, and it equals 0.028. So the answer is the fourth answer, which is 434 kips and 0.028. So this is it for our video today. See you in our next video. Thank you.